physics. And my name is Johanna Blue.
I'm Hanky Blue.
And today what we're going to talk about is magnetism and electricity. So we asked our subscribers and Twitter followers to ask us any questions relating to magnetism and electricity. And we have 7 of the most asked questions to talk about today. And so the first question is, describe how Maxwell, Franklin, and Michelson each contributed to the development of the fundamental forces. But first, we need to talk about what the fundamental forces are. And there are 4 of them. There's strong, electromagnetic, weak, and gravitational forces. The strong one is, obviously it's strong. It's a strong force. It is short-ranged, responsible for holding the nuclei of atoms together. It's very attractive, and it could be repulsive sometimes. The electromagnetic force causes electric and magnetic effects like repulsion between electrical charges or interaction of bar magnets. It is also long-ranged. It is much weaker than the strong force. It can be attractive or repulsive, and it acts only between pieces of matter carrying an electrical charge. The weak force relates to radioactive decay, and it's responsible for radioactive decay and also the neutrino interactions. It's very short-ranged, and it's also very weak, obviously because it's called weak force. And the last one is gravitational force. It is long-ranged. It's also weak. It's always attractive, so it's never repulsive. It acts between any 2 pieces of matter in the universe, since mass is its source. So those 4 are the fundamental forces. And then Maxwell, his name is James Clerk Maxwell. He contributed by electromagnetism, which is he saw analogies between the speeds of travel of electromagnetic waves and of light, and devised 4 mathematical equations which formulated relationships between electricity and magnetism, which is like electromagnetism. And then Franklin, who is Benjamin Franklin, he proved that the electrical nature of lightning. He proved the electrical nature of lightning, and also established the conventional use of negative and positive types of charges. And then the last one, Michelson, she'll explain that one.
Michelson contributed to the development of the fundamental forces. He introduced the light and electromagnetic radiation. He conducted an experiment which is known as the Michelson-Morley experiment, and he tested the speed of light and radiation. Another top asked question is, how are magnetism and electrostatics related? They both have fields. An electrical current flowing through a wire creates a magnetic field, which is the basis for most motors. A flowing current can produce a magnetic field, and an electric current can be induced using a magnetic field. Another top asked question is, how do electrons behave in a magnetic field? The electrons move through the magnetic field, and they would induce M, which is in volts.
Alright, the next question is, show the field around a bar magnet, and we're going to demonstrate that. Alright? So, I'm going to draw it.
So first, going to start off with the bar magnet.
And it has 2 poles, the north and the south pole.
Oh, that is so ugly. It's very hard to draw, so be patient. Hard to draw, right?
Not art majors. We're physics majors. And so she's just drawing the fields around the magnet. And the arrows would only they're only gonna point towards the south. South pole.
The bar magnet. South pole.
And like the lines, those are the fields. Alright, the fifth question is, describe how magnets behave. Show the interactions that two magnets can have. Alright, let's say I'm a magnet and she's a magnet too. So we both have north and south poles, and yeah. And so let's say my right hand is north and my left one is south, and hers is the same way. So once my right hand and her left hand touches, so mine's a positive and hers is a negative, so they're gonna attract. But if my left hand touches her left hand, it's gonna repel because they're both negative, so they're both south poles. So it's gonna repel. Alright, and that's the interaction. Number 6 is, two wires with charge are moving through them. Show an example of how these wires behave. So, in our research, we found out. Okay, so the wires, they are going to attract if the current flowing through them is direct. Is in the same direction, I mean. And they would repel, the wires would repel if the current is flowing in the opposite direction. And the last question we have is,
how magnetism and electricity are used together.
How are they both used in the real world? And there's many examples. We have a couple.
So you can do an electromagnet. You will need copper wire.
We can make our own.
Electromagnet. You need a battery. A nail. Copper wire, nail, battery, and some tape. So this is the battery, whatever you call it, and here's the nail. And you have your wire. What you're gonna do with the wire is you're gonna wrap it around this nail, and then the end of it is gonna be, you're gonna tape it to the end of the battery. And then say you have paper clips or something that'll conduct. That's magnetic, pretty much. So that once the nail is, well, this creates the magnetic field, and so then the nail will become magnetic and it will pick up paper clips. That's how it's used. And it's also used in like motors. So
okay, and now it's time for the secret letter. Oh, okay. Well, thanks a lot, Hanky. So, it says, you see, wire telegraph is a kind of very, very long cat. You pull his tail in New York and his head is meowing in Los Angeles. Do you understand this? And radio operates exactly the same way. You send signals here, they receive them there. The only difference is that there is no cat. We need to think about it. Is it Albert Einstein?
Ding ding ding!
Yes! I got it right. I don't need this anymore. Alright guys, well thanks for tuning in. Actually didn't need that. Actually didn't need this, sorry guys. Okay, well thanks for tuning in to Crash Course Physics. Shout out to the college for letting them use their markers, and we'll see you next time.